Distillation is simply defined as a process in which a liquid or vapor mixture of two or more substances is separated into its component fraction of desired purity by the application and removal of heat. The process is on, based on the fact that the vapor of a polymer mixture will be richer in the components that have lower boiling points. Hence, when the vapor is cooled and condensed, the condensers will contain more volatile components. At the same time, the original mixture will contain more less volatile material. The primary equipment employed in the process of distillation are distillation columns, which are designed to achieve this separation efficiently. Although the layman had a fair idea as to what distillation means, the important aspects that seem to be missed from the manufacturing point of view are: 1. Distillation is the most common separation technique. 2. It consumes enormous amount of energy, both in terms of cooling and heating requirements. 3. It can contribute to more than 50% of plant operating costs. The best way to reduce operation cost existing units is to improve tree efficiency and operation with process optimization and control. To achieve this improvement, a true understanding of distillation principle and how distillation systems are designed is essential. As stated, distillation is the process of heating a liquid until some of its ingredients pass into the vapor phase, and then cooling the vapor to recover its in liquids formed by condensation. The main purpose of distillation is to separate a mixture by taking advantage of different substances' readiness to become a vapor. If the difference in boiling point between two substances is great, complex separation might be easily accomplished by a single stage distillation. If the boiling points differ only slightly, many redistillation might be required. In the simple mixture of two mandatory slurpable liquids with similar chemical structure, the readiness to vaporize of each is undisturbed by the presence of the other. The boiling point of a 50-50 mixture, for example, would be halfway between the boiling point of the both substances, and the degree of separation achieved by a single distillation would depend only on a substance readiness to vibrate at reach temperature. The sample law first started by 15th century by the French chemist Francois Marie Raoult, now as Raoult laws. The term still is applied only to the vessel in which liquid is poised during distillation, but the term is sometimes applied to the entire apparatus, including the fractionating column, the condenser, and the receiver in which the distillate is collected. If a water and alcohol distillate is returned from the condenser, I must to drip down through a long room into a series of places, and if the vapor as it rises to the condenser, it might to propose through this liquid as believed. The vapor and liquids will interact as so that some of the water in the vapor condenses and some of the uncooled in the liquid evaporates. The interaction of explain is equivalent to a redistillation. This process is referred to by several names in industry, namely rectification, fractionation, or fractional distillation. If two insoluble liquids are heated, it is unaffected by the presence of the other and vibrates to an extent determined only by its own nature. Such a mixture on white points at a temperature lower than is true for either substance or law. This effect may be applied to substances that would be determined by overheating if distilled in the usual fashion. Substances can also be distilled at temperature below the normal boiling point by partially evacuating the still. The greater the vacuum, the lower distillation temperature. Basic component of the distillation column. There are a variety of configurations for distillation column as designed to perform specific type of separation. A simple way of classifying distillation column is to look at how they are operated. In this manner, the two major types are path and continuous column. Is about operation. The fixture column is introduced pathwise. That is, the column is charged with a path and then the distillation process is conducted. When the desired separation is achieved, a next part of fix is introduced. In contrast, continue column process, continue fixture, no interruption occur unless there is a problem or obsessed with the column or surrounding process unit. They are capable of handling high throughput and are the most common of the two types. The following discussion focused on the continue column. Continue column can be further classified according to 1. The nature of the fields that they are processing. Binary column, fields contain only two components, and multi-component column, fields contain more than two components. 2. The number of product streams they have. Multi-product column has more than two product streams. 3. Where the attracts assists when it is used to help with the separation. Attractive distillation where the attract fixed appear in the bottom product stream, and isotropic distillation where the attract fixed appear at the top product stream. 4. Type of column internal dry column where type of various design are used to hold the liquids to provide better contrast between vapor and liquids and hence achieve better separation. And the back column where instead of dry backing are employed to affect contrast between vapor and liquids. There are several important components in the distillation column. As of which is used either to transfer heat energy or a hand mass transfer. The major components in typical distillation are vertical cell, where the separation of liquids component is carried out. Column internal such as dry place and or packing, which are used to enhance component separation. A reboiler to provide the necessary for preparation for the distillation process, a condenser to cool and condense the vapor leaving top of the column, a reflow drum to hold the condensed vapor from the top of the column. The liquid reflux is recycled back to the column. The column internal are housed within a vertical shaft. The together with the condenser and reboiler constitute a distillation column, a thematic of a typical distillation unit with single feed and two product stream E shown in figure 1. The liquid mixture lasts into the process is called to fix. The fix is introduced usually somewhere near to the middle of the column to a dry round as the fish dry. The fish dry divide the column into the top, enriching or rectification section and bottom stripping section. The fish flow down the column where it is collected at the bottom in the reboiler. Heat is supplied to the reboiler to generate vapor. The result of his inburst can be any suitable fluid on top in most chemical plants. Heat is supplied to the reboiler to generate vapor. The source of his inburst can be any suitable fluid. On top in small chemical plants is normally steam. In refineries, the heating source may be outward stream of other column. The vapor raised in the reboiler is reintroduced into the units at the bottom of the column. The liquid removed from the reboiler is known as the bottom product or simply the bottom referred to figure 2 for the simplified view. The vapor travels up the column and as it exits the top of the unit, it is cooled by the condenser. The condenser liquid is stored in a holding vessel known as the reflux dome. Some of this liquid is recycled back to top of the column and this is called the reflux. The condenser liquid that is removed from the system is known as the distillate or top product, referred to figure 3 for the simplified view. This is figure 3, the role of reflux. The steam try and place you interchange replies. There are many types of try design, but the most common one are purple cup try, vans try, or sieve try. A purple cup try have a riser or chimney fitting over its hole, and a cap on the cover the riser. The cup is mounted so that there is a space between reserve and cup to allow the passage of vapor. Vapor rises through the chimney and is directed downward by the cups, finally discharging through salt in the cups, and finally purpling through the liquids on the top. Bubble jar or placed tower typically consist of number of shallow plates or tray over it, of which the liquid flow in turn on its way down the tower. The gas enter the bottom of the tower and it might to flow through a number of purple cups on its plate. The cup may be of various types. How they usually take the form of inverted cup, and these are slotted so that the gas escapes from them into the liquid in the form of bubbles. The layout of a typical plate is illustrated figure 4. The illustrated show the arrangement of bubble cup on the plate together with the result through which the gas enter the bubble cup and the dough come which carry the liquids from plate to plate. The inlet wall assists in distributing the liquids over the plate, while the outlets were maintain the desired depth of liquids. Purple plate tower may be referred to back tower when as the liquid tray is short low, thus the back tower could not be used effectively since the backing would not be adequately weighted. B. When a difficult distillation duty is required. 3. C. There is a risk that solid matter may be deposited purple plate tower, which can be fitted with manhole are more easily cleaned than Park's tower figuration. Infantry perforation are covered by little cups. Vapor flow leaves the cups, thus out creating a flowery for the basket of vapor. The lifting cup redirects the vapor to flow horizontally into the liquid, thus providing better mixing than is possible in silver tray. Silver tray is simply metal plate with hole in them. Vapor passed straight upward through the solids on the plate. The arrangement, number of plates of the hole are design parameter because of the efficacy, while operating around is of maintenance and cost factor. Sieve and Van Try have replaced the one highly trial of purple stripe in many applications. The flow of liquids and vapor through a tri-column is complete. Liquid flow through the dough comer by gravity from one try to the one pillar is referred to figure 5. A was on try and ensure that there is always some liquids holders on try and is designed such that the holder is at suitable height example, such that the bubble cups are covered by liquids. The vapor flow up the column and is forced to pass through the liquids via the opening on extract. The array allows for the passage of vapor on its tray is called a chief tray array. The outer vapor flow through the liquids on the tray above and transfer it to the liquid. During this process, some of vapor condenses adding to the liquids on the tray. The condensate, however, is richer in the less volatile component that is in the vapor. Additionally, because of heat intro from the vapor, the liquids on the tray pulse, generating more vapor. This vapor, which moves up to the net tray in the column, is richer in more volatile component. This continuous and intimate conducting between vapor and liquids occur on each tray in the column and bring about the separation between low polybond component and those with higher polybond. In a sense, a tray serves as mini column, with one contributing its share to the overall separation. As such, the more tray there are in a column, the better the degree of separation. Hence, the overall separation efficiency depends significantly on the design of the dry. Dry is designed to maximize vapor-liquid contacting, and hence focus is given to the extent of liquid distribution and vapor distribution achieved by the design. The more intimate the contacting between vapor and liquids, the better separation that the attract achieve. This means that few try will be needed in order to achieve the same degree of separation. This will result in lower construction costs and energy consumption. Dry alone do not always provide the ultimate contactor. As such, dry designs are sometimes assisted by the addition of backing configuration, backing or simpler passive or objects that are designed to increase the interfacial area available for vapor-liquid contacting. Figure 6 illustrates some common geometry of inner backing material often used in distillation application. These rows is simply to provide additional surface contact between the vapor and liquid in the column, and to do so without introducing excessive pressure drop across the column. High, high pressure drop means that more energy is needed to drive the vapor up through a distillation column. And as thus, there would be higher operating cost. Another very important reason why in the packing material are considered in debottlenecking column. A dry column that is facing throughput problem can be debottlenecked by replacing a section of dry with backing. The backing will provide additional interfacial contact area for the liquid fiber contact, thereby increasing the efficiency of the separation for the stem column height. In addition, back column tend to be shorter than dry tie column. The pass column is often referred to as continuous contact column, whereas dry column is called stacked contact column because of the manner in which the fiber and liquids come into contact. The function of repoler has already been discussed. The components are essentially heat exchangers that are used to transfer heat to bring the liquids at the bottom of the column to its boiling point. Refer also to the discussion in chapter 1. The principal type employ executive, cattle, simple, cattle tie repoler, internal repoler, and thermo-siphon repoler. Example of a type are illustrated in figure 7.